Hi, you are watching Arduino Countdown Timer Web UI. My name is Kashif Baig, and I will be demonstrating a project that has been developed using a new MVC framework and which promotes a professional software design. This is the fourth of 6 projects in increasing order of complexity. Visit my website to download the source code and framework libraries, and whilst you are there you can find out about my ebook, Arduino Web Development Pushing the Limits. It lays the foundations of a professional approach to web development using the Arduino platform. It has lots of coding examples and exercises to get you upskilled quickly. And so back to the presentation. The source code will build using the latest Arduino IDE, but I recommend using the freely available Visual Studio Code if you want to take advantage of Arduino server pages. Watch until the end of the presentation to find out more. To get the Countdown Web UI working, you would need a network-enabled Arduino or compatible, and it will also help if you have a 9-in-1 sensor shield. If you don't have one, then you can adapt the source code for your requirements. I'll be using the buttons, LEDs, and buzzer. If you're using a classic Uno, the shield LEDs won't be available for use. You will need to attach your own LEDs. For this presentation, I will be using an Uno R4 WiFi. Connecting a web client to the R4 WiFi, we can see the countdown clock and the timer configuration web pages. The timer start and stop can be controlled either by the UI or the board buttons. Be aware that the UI will lag slightly behind the actual timer, which is running on the R4 Wi-Fi. So in the class diagram, we can see the dependencies between the different classes. I/O control implements a hardware abstraction layer for the buttons, LEDs, and the buzzer. The countdown timer manages the countdown. The model classes implement model binding for HTTP post, interact with the countdown timer, and have corresponding views for rendering HTML web pages. Time view renders just the clock value for AJAX requests. The layout view classes implement a master web page that has client scripts and navigation links. The controller filters the HTTP request and serves an appropriate view. And do look at the main application loop. Be sure to download the source code and adapt for your circumstances. There are several examples of AJAX in this project, and the topic is covered in my book, Arduino Web Development Pushing the Limits. A major advantage of using Visual Studio Code is that dynamic HTML and JSON content can be authored using Arduino server pages or ASPs. ASPs feature server-side scripting tags that professional web developers will be familiar with. To be able to use ASPs, follow the guidance on my website to configure your computing environment. New web projects can be created from the command line and opened in Visual Studio Code. If I now deploy to an Uno with Ethernet capability, we see starter web pages and a responsive navigation menu. If I paste some code into one of the ASPs and redeploy, when I refresh the browser, we can see the updated web page. And that is how straightforward it gets when you integrate the View Builder with Visual Studio Code. If you have any questions about this project, please leave a comment at my website. And remember to visit for updates and new tech projects. If you're watching on social media and found this presentation useful, please like and share. Thank you for watching.